Here we're going to take a look at section 10.5, which is expressions containing multiple radical terms. So things we need to do, we need to be able to add and subtract radicals when we have like indices and radicands. And just some technical terms here. When we're looking at a radical symbol, the actual thing that you think of probably as a square root symbol, that's what the radical symbol is. When we're doing square roots, the index is 2. For a cube root, the index is 3. So the index is that little number on the outside of the radical symbol. And when we're talking about radicand, it's what we're taking the cube root, square root, or whatever root of. So the way we say this one is the cube root of x minus 4, the index is 3, and the radicand is x minus 4. All right, so when we have radicals, if we have the same index and the same radicand, you can combine them. It's some way to think about this. You could kind of think about this as like replacing root 3 with an x. So this would just be 1x plus 2x, and we would know that that adds up to be 3x. Now, we're not saying that radical 3, or I'm not saying that radical 3 is a variable here, but it's just kind of a useful way of thinking about it. So what we have here is 1 root 3, there, it's not really written, but it's there, plus 2 root 3. So overall, what we have there is 3 square root of 3. So again, same index, same radicand, you can combine them. Same with subtraction, it works. So here we have a radicand of y and an index of 4 for both of them. So same radicand, same index, we can do the subtraction. So this would be 7 root 4 of y and minus 1 root 4 of y. Just kind of add that in there, which would give us 6 fourth root of y. I shouldn't have been saying root 4 of, fourth root. Okay, and this works whether you're doing just one subtraction or one addition or multiple. As long as we have the same index, which is the 5s here, and the same radicands, which are the 3s there, we can combine them. Start here, 6 fifth root of 3 plus 4 fifth roots of 3 will be 10. Ooh, that's pretty ugly. And then minus 2 fifth root of 3. 10 minus 2 is 8. Again, same radicand, same index. So we have 8 fifth root of 3 is our final answer there. All right, sometimes in order to be able to do this type of simplification, we need to first rewrite one of the radical symbols in order to get the same index and the same radicand. So with this first example here, for square root of 18 plus 2 root 2, we have the same index. They're both square roots, so they can't see it, and it's not written, but those would be a 2 for the index. The radicands are different, though. So we'd have to look, is there any way we could rewrite the square root of 18? I'll just do that off on the side here. Well, that is 9 times 2. So the square root of 9 times the square root of 2. And the square root of 9 is 3. So we can replace the square root of 18 with 3 square root of 2. So that would be 4 times 3 times the square root of 2 plus 2 square root of 2. And that would be then 4 times 3 is 12 root 2. We don't multiply and distribute the 4 times the 3 and the 4 times the 2 because this isn't addition. We use the distributive property if it looked like this, 4 times 3 plus the square root of 2. Then you would use the distributive property. We distribute over addition. Multiplication, it's just 4 times 3 times root 2. It's all one multiplication there. And then 12 plus 2 would be 14 square root of 2. So this whole thing simplifies to 14 square root of 2. And that's really kind of the reason why we're doing this, is we can take something that's pretty complicated looking and simplify it down into something maybe a little bit less complicated looking. All right, 5 times the square root of 5a cubed. There's really nothing I can do with that 5, but a cubed is a squared times a to the first. So a squared, we can take that out. So 5a square root of 5a. And then square root of 80. Well, easiest thing is 10 times 8, but it's also 80 is the same as 16 times 5. 10 times 8, I just took the 2 off the 10 and times the 8, that gives the 16. That's just kind of the thinking that was in my head for that. So I'll do this off to the side. Minus 2 root 80a minus 2 times the square root of 16 times the square root of 5 times the square root of a. And then the square root of 16 is just 4. So negative 2 times 4 times, and I'll put those back under 1 square root, 5a. So that's negative 8 square root of 5a. So we can replace minus 2 square root of 80a with negative 8 square root of 5a. So minus 8 square root of 5a. Now, do we have the same radicand and the same index? We do. And indexes are both 2. Radicand is 5a. It's a little bit tricky, though, in terms of combining these. It would kind of be like this. Let's go just erase this for now. If we remember, we think about this as just a variable. So let's say we had 5a times x minus 8x. Remember, I'm just replacing this 5a, square root of 5a with x. There's actually nothing that we can do to combine that because this is not the same, right? We can't. This is not just a number. 5a is 5 times a, so we can't really do anything about that. So actually, this one is as simplified as we'll get. All right, so multiplying square roots. This is over subtraction, and I know before I said we distribute over addition, but addition and subtraction are very closely related. In fact, we could say plus a negative there. So you can distribute over subtraction as well. So we're going to multiply in on both of these. So this would be the square root of 7 times 1, which is just the square root of 7, minus the square root of 7 times the square root of 7. That's just going to be minus 7. Remember, anytime we have the square root of a number times that square root of that same number, the output is just the value. So for example, if we had the square root of 5 times the square root of 5, that would be the same as the square root of 5 times 5, which is 25, or 5. So same number under the square root, your output is going to be that. So that's that. Square root of 7 minus 7. When multiplying, and we see this, we have to remember we can't just distribute it. We have to think of it as a perfect square. So that would be 2 plus the square root of 3 times 2 plus the square root of 3. We rewrite it. And when we rewrite it, hopefully then we remember we're going to do the first times the first, then multiply the outer values, the inner values, and the last values. We're distributing everything there. All right, so first times first is going to be 2 times 2. So 2 times 2 is 4. The outer, 2 times 3, square root of 3. 2 times the square root of 3 is just 2 root 3. And then again, 2 times the square root of 3 is another 2 root 3. And then the square root of 3 times the square root of 3, that's kind of like the square root of 7 times the square root of 7. We just get 3 there. And then combine our like terms. 4 plus 3 is 7. And then 2 root 3 plus 2 root 3 gives us a total of 4 root 3. All right, so when you see a problem where you have something like that squared, you've got to remember to write it out and then multiply using the distributive property like that. All right, let's take a look at another one of these. Multiply the first times the first, we get 3 times 3 is 9. And then the outer, 3 times negative root 5, so that would be minus 3 square root of 5. And the inner, plus 3 square root of 5. And then the last, that's going to be a positive times a negative. It's going to be minus root 5 times root 5. Well, that gives us 5. Notice here, those inside terms, plus square root of, plus 3 square root of 5 and minus 3 square root of 5, those go to 0. And then 9 minus 5 is just 4. That whole thing simplifies to just the number 4. It's actually chose this example for a reason, and we'll see that on our next page. Let's take a look at one more here. First times first, square root of 6 times the square root of 6 is 6. And then the outer, minus the square root of 6 times the square root of 3. Inner, plus the square root of 6 times the square root of 3. And then last, root 3 times the negative root 3 is going to be minus 3. Square root of 3 times square root of 3 is 3. All right, so again, those cancel. Positive and negative of the same thing. 6 minus 3 is 3. And again, we have that disappearing, canceling, and simplifying to just the number 3.